Okie dokes. Live. 12 seconds. Hey everyone, Lazy Ben. Let's get music. Some kind of music. Need to look for more music. Just did a little bit of YouTube-y stuff there. What I was saying in that YouTube take there was, I'm going to rework this today. Been thinking about changing this, disconnecting it from NPCs. So that's the plan for today. Just want to keep forgetting to upload the VODs to YouTube, so I'm just going to sort that out a second. I need to put a note: upload VOD to YouTube. When my alarm goes off, actually, I might put that on the alarm. So last that one was 5:33:09. So we want to upload that one. And that's AI 5. And then we want to upload, sorry, I'm not even doing it on stream there, upload that one, and that's AI 6. I'll make thumbnails for these. Rename them later. Alright, cool. So yeah, I'm going to rework this design. I think so the plan is, I wish this error would go away. The plan is to create a behavior controller, pull all these NPC behaviors out of the NPC class and have everything go through the controller, because you might want to attach behaviors to things that are NPCs basically. So let's do that. So we're going to add a new item, behavior controller. And then all we're going to do for the moment is just get everything to work in this file instead of the NPC file. It means porting it over to a new file for now. So this, well, hang on. Let's just create the CPP file for a second. So we're going to need that too. So this NPC behavior action renderer and NPC behavior renderer. Well, let's all of this actually. All of this go in here. And then all of the behavior stuff. So that, 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 that. All this stuff is going to go in the controller instead. All right. So it's all out of NPC now. Game brains can disappear. All this stuff, this forward declaration stuff, can disappear. Interesting, we are forward declaring and then including the file. Let's see if we can get away with not including the file. Object UI renderer, I don't think we need that anymore. Or game location. Don't think we need either of those. We've got more things. We've got tick behavior, brain. We've got, so those disappear. Into here. So if we are actually creating an array of them, we do need to include game brains. We might take this tick away for now. This was all a bit unsure of all this yesterday. This tick behavior will take away. Like, we can still go through the NPC to tick the behavior, but it'll work a different way. Right, let's just check this works. Compiles. Game location. So we need to forward declare game location. Interesting, now we're passing it by value. Why are we doing that? I'm just going to change that to not passing by value. I would have done that for a reason though. That just means we can forward declare game location as a struct. Right, so NPC compiles, the behavior controller compiles, before we start, I do want to change the name of these and stuff, all of these structures, but we'll get it to working how it was before. So in game.cpp, right, we've got behavior. We've got some kind of tick NPC brain there. Which comes from the patrol. Tick NPC brain, tick NPC brain. So we'll just return false and we'll just put a to do there. All right. So the behavior renderer. So all this now is in the behavior controller. Let's set up some YouTube stuff. Keep forgetting to film these little bits of YouTube content for the videos. Just stop forgetting. Okay, so that builds. Get that going for 10 minutes. So let's just film for 5 minutes. So set an alarm. 09 56. I'll say 57. Okay. So let's just do a full build of that and let's see if that works. And then in Notepad, I want to change this because this isn't the best way to do it. We want to change this to the class name. So right now only NPCs can go and patrol, so tick NPC brain. Tick patrol behavior. Is called in here for a specific NPC. So it's specific, it could be an entity, that's the thing. I've called it NPC ID, but it's only a U32. So that kind of needs working out. I mean, okay, no, the good thing about that is we can say tick entity brain, then we can use the behavior control. Yeah, so that'll be fine. This is already turning into a good design change. All right, so let's just see if nothing's broken. So let's just open the patrol Yeah, we'll open the patrol up, and then we'll use the patrol to open the brain up. It's a test, open brain. Okay, so everything's working the same, which is what we want. Now we want to actually start renaming some of these things. Get them away from NPC stuff. So let's just not forward declare that. Going to forward declare any of those now because we're including the actual file itself. So we're going to call this behavior test. I'm going to call this behavior types. Well, let me rename that. I'm going to rename this get behavior types. And then I'm going to call this behavior action test action. I'm going to call this behavior action types. Behavior action types. And then this is the NPC behavior renderer. We're just going to call this the UI behavior renderer. I'm going to write behavior, read behavior, reflect behavior. And then this is UI behavior action renderer. Binary write behavior action. Binary read behavior action. Okay. And then these ones are not NPC either. Alright, that's my alarm to stop my time lapse. Cool. We'll do another one. All about the YouTube today. Ooh, break my monitor. That's not going to work. I'll just change my monitor position. 1 second, let me just put this back. All right, cool. Okay. Ban this person. Just doing another time lapse. All right, cool. So none of these now are to do with the NPCs, which is good. Oops. Get these compilers out of the way. G behavior types. Get behavior types. Behavior action types. All right, cool. All right, so that builds. So also what I want to do is get rid of these get names. We don't need these because we reflect them now. The names are here. So we don't need get name. Which means that is going to cause some compiler errors in other places, which we can fix. So get name. So this is we use a T there, and we'll do if reflect type T get type name equals name. It's not static. Same here. Reflect type T get type name equals name. And here and here. And here. So this will rename the names of the behaviors on the actions to the names of the classes, which is better really. Real. Okay, so let's do a global build there, and we'll just see if there's anywhere else that's calling get name. Calling get name, yeah. Okay. So we need to using T standard K T equal type of X And then this is reflect type t.get type name. Here I can see there's also going to be a compiler. Okay, cool. Just check this. Nice one. There we go, I've got a couple of YouTube things there. YouTube ticks, right? Reflect type t.get type name equals name. Okay, using t equals standard to kt tuple type of x, and then this is just reflect type t get type name. Right, so let's just load this patrol, this behavior up again, and it won't work now because we've changed the name of all of the change the name of all the behaviors and things. So the default behavior is behavior test. The action is behavior action test action there. And that was bacon. And this one didn't have an action. Yeah, we've got a weird kind of gap there. And there. Might fix that gap. I think all is just because the left panel in the editor, the left panel needs a separator there. What was it called? Brain editor. iBrain node. Tick left panel. So let's just do canvas draw separator there. Let's open this brain back up. There we go. Cool. Okay, that's fine. Right. So now we need to actually do some things with the behavior controller. So I think on NPC, right, when we create the NPC, we kind of have to give them a behavior controller. Do we do it by default? We probably do. Because the entity state types spawn. We create all the controllers here actually. Maybe we do it here. Okay. So we want to include the behavior controller. And then we want to just basically do the same as we've got all of these ones. So behavior controller, create behavior controller, U64 ID, optref behavior controller, get behavior controller, U64 ID. Might do one with eMPC ID as well. And then we want array behavior controller reference get behavior controllers. And then we need an array of them. So, shut down the game. We want to do behavior controllers.empty. And then when we create a behavior controller, let's just open a new game state window and have a look at create something. Create tech controller. It's the same basically. So we're just checking if it exists. If it doesn't exist, make one. Auto index equals behavior controllers index of ID. Okay, so a behavior controller needs an ID. And it also needs an operator to get an ID. So bool operator equals uses for other ID. We'll send that into the source file. If index is less than, well, equals behavior controllers dot get count, index equals behavior controllers dot in place ID. So it definitely needs a constructor that passes the ID. We'll send that also into the implementation. Okay, cool. And then should we just return behavior controllers index. Get behavior controller by MPC ID is just return behavior controllers.find by, well, let's just do get behavior controller standard to underlying ID, and then this is behavior controllers find on ID. So I think actually we need to create behavior controller for the MPC ID as well. And that just returns create behavior controller for standard to underlying ID. Get behavior controllers just returns the behavior controllers. Right. So I think with Jenny, so if we do entity state types, and when we're going to spawn Jenny, we're just going to go game state dot create behavior controller ID. So they don't have anything, they don't have for the MPC actually. So we'll just leave that, keep it the same. So that creates a behavior controller for Jenny. With no brains on it, or behaviors. But she gets one. So that means in the game where we actually tick NPC brain, we need to get the behavior controller for this NPC. So this is going to be not tick NPC brain anymore. This is going to be tick entity brain U64 entity ID. And then in game patrols now, we're just going to do tick entity brain and tick patrol behavior. Whatever, that can stay like that. So tick NPC, tick entity brain, NPC ID. Right, cool. So that's going to go if auto BC equals get game state we're going to tick them here though. So it would be get behavior controller entity ID. It would be BC tick, which doesn't exist. But do we actually want to do this here? Tick patrol behavior. I think we would want to tick. We would just want to tick the behaviors once a frame. So we'd have something like tick behavior controllers. So it'd be something like auto BC in behavior controllers. BC tick like that. And the game doesn't actually have to do that. So the game state tick patrol, NPC patrols. Fast travel controller, handle, patrol. So the fast travel controller can handle the patrol. So I think maybe we do get behavior controller. NPC get ID. So we'll do auto BC. BC and BC handle patrol. Return. So the behavior controller is handling the patrol. Or something like is active, is running. So we can have bool is running, and that returns false to start with. Probably has to be. So I think that has to kind of come first. The behavior controller is running. The behavior is taking control over the NPC in this state. So we don't need to do anything. I think I like that better than going through the patrol and doing this. And then game doesn't need tick entity brain anymore. And get rid of that. So it says if the patrol is if there's a behavior controller and the behavior controller is running, then we don't do anything with the patrol. Okay. That means that the patrol will, if the behavior controller is not running, the patrol will just default to what it normally does, which is just walk into the destination. And then if something happens in the game which kicks in a behavior, the patrol will cease to run. We might be able to take out these pause reasons as well. Yeah, I mean we'll leave the pause reasons for now because that's all working. So Basically what we need to do now in the behavior controller is when we create one, wherever that is here, we need to look in the game brains and see all the behavior controllers associated with that entity ID. We need to know that all the brains, associated with that entity. Right now, we only link it with game patrols. So a patrol has in it an NPC ID. Basically, we need to populate all the brains. Associated. Or at least all the brains associated with it. How that works. So we go. How do we get all the patrols? So I think for each patrol state, can do that, can't we? Can find a patrol. So how do we get all the patrols? So can we do a standard span? Patrol group? No. Find patrol with patrol ID, so we can get all the states. And we can get the patrol for each state. And then now we have an NPC ID and a patrol. So I think what we might do, make it a bit easier, we'll say tier A. Weak pointer patrol. Get patrols U64 NPC ID or U32 NPC ID. Oops. Let's try this. So we do TRA weak pointer roll result. So we go for auto group patrol groups values for auto patrol group get patrols. If patrol dot, oh, I know what we can do. We can just turn a weak pointer to the patrol, or we can actually return the patrol IDs. Now we'll just say if patrol get NPC ID equals NPC ID result.add standard to address. Patrol. Seem to work. No, it's not to address, it's address of. Oh. Okay. So now we need to go auto patrols. Well, for auto patrol, get game patrols, get patrols for ID. So I have to do standard, no, VM truncate U32 ID. So this needs to include game patrols. Okay, it's not there, it's the BM engine game patrols. All right then. See if we can find all the game patrols for this entity ID. And then we can get the behavior And then we need to get the brain with the behaviour, with that behaviour attached to it. I think so it's got default behavior name test, which is not correct because we've changed that. So that did work though. Let's just check. Yeah, that was good. Which means we need to change the default behavior name for the patrol. Oops. So the default behavior name is behavior test. So I wonder if here we put in the actual put in here where we can change X rather than here, because this is only going to be, this is the controller for this behavior. This is going to be the thing that wants to put in the variables. Yeah. Anyway, let's save that. So this behavior test. If we do that, then the patrol's going to actually have to store the behavior itself, which is probably fine. Probably the way to do it. I think that's going to be the way that we do it. So the patrol init has the default behavior name behavior test. I think it actually needs the behavior in it rather than just the name. How easy would that be to do? It would mean a patrol that has to be dynamics, that has to be hybrid storage. That's what that means. So just like the game brain. So game brains. That's a brain behavior. So it's not hybrid storage. We could make it a brain behavior. All right, let's just check in this before we change anything. So this just becomes the default behavior. Yeah. That means that this needs to include game brains. This is brain behavior. Get default brain behavior. Default behavior. So this is actually not going to be a string anymore, which means what does this mean then? In the patrol generator, this needs a brain behavior. So this needs to include main brains. And then the behavior control, the behavior generator, whatever it's called, the patrol generator. Needs to actually pass through the default behavior. And the patrol editor so this is default behavior name. Okay. So we need to do get game dot ensure NPC behavior storage default behavior dot name default behavior dot storage, and that will make sure that it sets it And then we need to do canvas.draw separator. And then we need to do on draw got draw behavior action, draw game brain. No. Canvas. Default behavior.name, default behavior.storage. So I think this also needs to be called undraw behavior. Okay. Now let's just see if we can forward through the behavior arguments with the patrol editor. If this works, it's a good opportunity to have a 2-minute coffee break. So that means in the brain editor now, we're just selecting the behavior, but we're not actually setting, we don't want it to set any variables on the behavior. That has to be done on the patrol. That's a good, yeah, so we had them the wrong way around, so that's good. So, so I wonder why the patrol state needs the default behavior name. Might not need it anymore. I'm going to take the default behavior name out. We have to get it from the patrol. see what kind of compile errors this has triggered. None. Brilliant. Right. So in the brain editor now, we don't want to do that. We don't even actually need to store the behavior itself. We just need to store the name of the behavior. But it doesn't matter. I'm not going to unwind that because eventually we might want to. I don't know. Okay. So a lot of this stuff now needs rebuilding. So I want to rebuild patrols. Brains don't really need rebuilding. But okay, so the patrol now has in it an actual default behavior. Empty at the moment because we need to set it with the editor. So if we open boat patrols Jenny, we can set the behavior to behavior test. We can say that, let's make it 3. And we'll open the brain, and that's just a behavior test. This is the brain for behavior test. Alright, so let's just run that again. Let's see if we get it. If we get it, we can have a quick break and have a cup of coffee. Another one. Default behavior. Behavior test storage x equals 3. Brilliant. There we go. That's great. Okay, so I'm gonna have a quick 2-minute break and have a cup of coffee. I'll make a cup of coffee and I'll be back soon. All right then. So we basically need to get the brain. So if patrol get default behavior, so auto behavior, because patrol get default behavior. If behavior.name.set, I'm going to go get game brains, get brain ID. So how do we get the brain state based on the behavior name? Can we not get the brain based on the behavior name? So we won't get brain. Optref brain, get brain, const use string view behavior name. For auto brain, what is it? For auto group brain groups values. So we've got the brain, want the brain find on the behavior name. So we have a name and a behavior name, so I don't think we can do a find. For auto brain in group dot brains. If brain get behavior name equals behavior name, return brain. So what that means is we can get a brain if auto brain equals get game brains, get brain based on the behavior name. And then we want to do auto index equals brains dot add brain. Add unique brain. So one of the things is the initial state of the behavior is stored in the patrol. Might be more than one patrol. Because what I want to do is I want to go brains index.behavior. Set behavior. behavior. Basically, something like that for this brain, which makes me think that this can't be brain. We can do struct behavior brain, which has got what's it called? A brain behavior. Now I'm going to call this brain instance. I'm going to have the brain. And then we're going to have the brain behavior. We could inherit from brain. And then have an instance ID. And then we could have protected brain. And then this has the brain instance, and it has instance ID. The bit wielder, hey, how's it going? I'm doing okay, thank you. Still working on NPC behaviors. I'll be feeling a little bit better today. I'm getting there with this design now. It's coming together. This is a brain instance now. So there's an instance ID. So when we make it, we do brains.add unique. So this is in place. Brain, and then is that even loud? New pair of headphones, awesome. I need a new pair of headphones. I've just got these rubbish things. Are they decent? They sound good. Yeah, nice one. Yeah, I used to have a really good pair of headphones, and then when my kid was born and went through the toddler stage, she slowly destroyed them. Logitech G435. Ooh, nice. Check that out. Very similar actually to the ones that I used to have. I used to have those blue ones, I'm sure. Or something, they were Logitech and they were blue. And they looked like that. Yeah, they're really good. Really good headphones. Had them for years. Yeah, I mean, I think it sounded awesome. I used to do all my gaming with them. They were mint. They were really good. So I might make Brain Instance. Brain. Can I actually do this? No. Can only take a Brain Instance. So I might not do this. I might put the brain there. And then do copy brain over. And the instance ID. And then do brain. Can't do that. What are you up to today, the bit wielder? Are you just chilling out? Am I still trying to get better? Oh, brilliant. I'm glad. Yeah, nice one. Instance ID, brain, behavior. We'll just make them. It's a bit annoying that. So we want void set behavior. And then behavior. Call this new behavior. Behavior is new behavior. And then we can do set behavior. How does that work? So we want the instance ID, the brain, and the behavior. So that's brains. Let's get count +1. And then that's the behavior. Need to do a copy constructor. Work fixing a TV? Oh yeah, you said yesterday. Is it going alright? Can I just get away with this? Default copy. Move brain. Can I get away with that? Nope. Oh, it's a sign. It's not. Okay. Oh, that's annoying. Well, we'll take that away. Should have worked. Maybe not. Backlight issues. Right, okay. It's good skills if you can fix stuff like that. Really good. Do I even have to write this? Can I get away with just doing brain? Brain. Yeah, okay, cool. Yeah, whenever I've had any problems, I've never tried to fix them. I'm not really a hardware guy. Don't know much about it really. Okay, let's see if this works. Touch wood though. I've never really lost a monitor. Lost TVs in the past. And iPads. Let's just dropping iPads on the ground by accident. Alright, I'll get this built, and then basically this should create a brain instance for all of the patrols involved with this ID. Assign the right behaviour. And then when we tick, we need to get the patrol, we need to get the brain state that we're ticking, if there is one. That's the next thing we need to do. Kind of nearly at a point where we can get an NPC to do something with these brains. Which would be exciting. A few test cases. Think of a decent test case, really. Don't know. Eventually with these brains, the good test for them will be I want to build in combat with them. That's probably going to be next week. Oh, interesting. I wonder what would cause that to shut off. It's like it overloads or something. All right, cool. So, got the brain. And it has the right behavior. There's nothing, it's got 2 in it. We want to overload it or override it with 3. So brains, we have 1 brain, instance ID 1. Maybe the instance ID should be the patrol ID, actually. Yeah, so the instance ID is going to be the patrol ID. in this case. Okay then. So when we tick, we need to go. So if we do get game brains, get game brain state for the behavior name. So if we do, we have to go through each of the brains. So do we want to go through each of the brains, or do we want to go? We want to get the available patrol. So for so if auto patrol equals get game patrols, we do this. Find available patrol. The patrol ID, the level, and the NPC ID. So auto level equals get game state, okay, current level, if not level, return, find available patrol, or do we need to do that? We could just find, we could use it with a patrol ID. Then we can check if it's available. So this is the first available patrol. It's the one it takes. So we can just use the patrol ID. So we probably have to use this one to get the same patrol. So it's level. If not patrol, return. And then we'll auto behavior on brain. Find patrol, get ID, patrol ID. If not brain, return. So brains also has to be found on instance ID. Ooh. So we have the finding on the other ID here. Does that work? Yeah, that's not. That's finding it on the actual brain ID. We need to find it on the patrol ID. I think it should override it. Let's just try this. I'll either override it or it'll say that you've, yeah, you know, you say you've created the method twice. Let's just check. Oh, nice one, the bit wielder. Yeah. So using like an oscilloscope or something like that to read the signals. Oh, cool. Check that out. Oh yeah, nice. My electronics skills. I did it at school up until A level, so up until I was 18. But then after that, I have not really done much at all. Oops. Alright. So when we tick it, where are we finding it? Yes, the instance, we are comparing instance IDs. So we have the right brain. So now we can actually tick the brain. We need to actually make sure that the brain, so we need to get the brain state, the active brain state for this brain. So it'd be like brain state equals get game brains, get brain state for the brain, get behavior name. If not brain state, if brain state is not equal to available, return. Double sync and triggers. Wow, cool. So what's double sync on triggers? I don't really know anything about oscilloscopes. No, there'll be multiple brain states for a behavior name. So this needs to be get available. So that's not correct. Wrote that when I was tired. So this needs to be get available brain state. All right, I see. So you can compare, yeah. Nice one. So we need to go return optref brain state. So we're going to go for auto state in brain states. If state dot behavior name is equal to the behavior name and state dot state is equal to e brain state available return state. So yeah, we'll get the available brain state. So if to say if there's not the brain state, return. So this is the available brain state now. So we've got the brain and we've got the brain state. Oh yeah, nice one. That sounds pretty fun. So here when we find the available patrol, we'll be able to see if the patrol is... Because I also want to be able to put these brains on the patrol activities. So we'll be able to see if the patrol has got a current activity, and then we'll get the brain from that. Right now, I'll just get the brain from the patrol ID. So here we'll be able to set up more brains based on the patrol. So the patrol will be able to look for activity nodes, look for brains set on the activity nodes. Right then, so so we want to tick so I think the brain instance needs with the current route we're on and the current node we're on. And if the root, if a different brain state comes back, we need to swap to the new root. That's the way to do it. Yeah. Yeah, sure, yeah, too. There we go. So the brain ID is 059. The brain ID is 059. I'm going to say if brain get ID is not equal to brain state brain ID, return. Now they should be equal. Rather the brain stop than get into a weird, if they're not equal, if they're not the same brains, then it's going to get into a weird state there. So brain instance, we need U64 current root node ID. U64 current node ID. So we're going to say if brain current root node ID is not equal to brain state root node ID, then we need to swap brains. Swap brain trees there. And we need to tick the actual brain. Yeah, let me see an example. I'm just going to be back in 2 minutes. I've just got to do something 1 second. Hang on a second. I don't really use Discord. Let's have a look. I have it on there. I set it up a while ago. find Discord confusing. Maybe it's because I'm old. And how to make a good UI, yeah. Put it in the general discussion one, or there's a current projects one. Yeah, put it in current projects. Are you able to access that? Got Discord open. I haven't really looked in it in a while. Oh, you are putting it in there. Yeah, cool. I've seen it. I need to do a bit of reading up on Discord, to be fair, because I know it's a big thing on Twitch, innit? Yeah, nice one. I can see it. So this is like the pulse. It's really cool, man. I'll make you a founder. Let's have a look. You a founding member there, the bit wielder. Nice one. Thanks for joining the Discord server as well. Right, I'll be back in 2 minutes. Just need to go to the loo. right then. Yeah, it looks like interesting work, that, for sure. I have used oscilloscopes, but like I say, it was back when I was at school, which was quite a while ago now. 25 years ago. Something like that. Yeah, you can. So like, so is the channel sync like, you've got 3 signals, or is it these 2? These 2 here. Yeah, compare them. Alright, cool. 4 channels. Yeah, nice one, that. Cool little interface as well. Get back to the notes on here. So we actually done that one. And that one. And that one. So we've actually done all I wanted to do this week already. So let's put another one in. We want to run behavior or tick behavior trees. Game. Okay, so we're on ticking behavior trees in the game now. So we need to swap the brain trees if that happens. What does that mean? I think we should do something like brain set current root, and that's got to go through, and then it's got to call a method on the behavior, right? So so we've got to do something like, we won't call it set current root, we'll call it like begin U64 root node ID, and that's got to go current root node ID equals current node ID equals root node ID, and then we need to do behavior storage. So we need to go for each type get behavior types. So we'll just pass through this, right? And then we want like a concept. So a behavior type is like behavior test. So we want on begin. And then we want a concept for that. So we want has so we'll say behavior as on begin. Is that the right way to write that? Okay, so this is on begin. I'll begin. Brain state, root node ID. It's actually has begin. It's not has on begin. Sent another thing. Oh yeah, cool. I'll have a look. Ah, right. Is this what you mean? Oops. Yeah, nice. So what's a MOSFET gate? What's that? So its behavior actually has begin. So if, oh no, it's on begin. It is on begin. So let's just put a breakpoint there. So we want to go using t equals standard. If Response text behavior has on begin if auto data equals oh wow, that's cool. Yeah, it's like a remote desktop thing. Yeah, that's awesome. Yeah, we have here, so in the office here, there's remote desktoping into a brewery actually. So you can actually control like a whole brewery, which is not located here. It's in the town where I live from the computer in this office. So the person who works here with me runs all that stuff. And that's amazing. That's proper electronics. It builds all sorts of stuff. Yeah. So you can do things like you can start like brewing beer from his computer, which is pretty awesome. Yeah, it's definitely fun. The brewery is massive. You could definitely do a homebrew stuff like that though. This brewery's like one brew's like, I don't know, like 20,000 litres or something. So it's definitely industrial. Okay, so the behavior itself, story, what's it behaving about? The storage is part of brain. The behavior is part of brain. So we want brain behavior. Get behavior. Returns behavior. Yeah, man. Loads of it's automated as well, so you don't even have to click buttons. Like, it runs itself. I think you have to set what type of beer you want to make and what time you want to make it, because they brew overnight. So they start brewing like I know, like 2 o'clock in the morning or something. Alright, so this should begin the actual behavior tree. So we might want like an on interrupt as well, but we'll get to that if we ever need it. Because obviously, like behaviors, it might be on a behavior. All right, how's it going? Okay. Are you okay?
Yeah.
Yeah, good, thank you. Interrupts, not hardware interrupts. So what's going to happen is, so the behavior trees, so a brain has multiple trees, and dependent on the game state is dependent on which tree gets ticked. So if you're ticking this down a tree, then the game state changes and all of a sudden that tree is not available. In nice ticks, it needs to tick another tree. So it might be nice to interrupt that first tree and say, oh, you've been interrupted. So if you need to know, that would be good. But I won't do that until we get to that case. Yeah. Yeah, not that type of interrupt. I'm alright at the moment, thank you. Yeah, thanks. So we begin it, and then we call on begin on the actual behavior itself. This just allows it. This will allow a behavior to just initialize itself. MCUs, what are MCUs? All right, okay. Yeah. I did some microcontroller stuff in electronics again at uni. Not at uni, at school. And then we did some assembler with that. You could either build the hardware or you could program the hardware. So I chose to program it instead. With assembler, the assembler, I can't remember what assembler it was. Made a guitar tuner that kind of could tune guitars, kind of. Okay, so that doesn't do any. So that's a good place where we can enter. Right. And then the brain instance needs a tick. So we just call brain tick. And the tick needs to return whether it's whether it's running or not, because we need to know if the behavior controller is running. So that's going to be to do with this, get available brain state. I'm going to say running. Okay, well, the brain definitely going to need a state. So enum class eBehavior state. And have unknown, success, fail, running. So if we try and tick the behavior, so is running is the state is equal to running, I think. The state of the overall behavior controller is equal to running. So we do put it back to the unknown state there. So we do state. So we'll do state equals unknown. And then the tick has to return the behavior state. And that means that this tick, so it's just state equals that. Is that often the case? Yeah, man. Frustrating. So we say it's unknown. So if the whole thing succeeds, what does that mean? I think that's fine. So the brain can just return running if the brain is running, as you would expect. So if we do running here, if we return running, this should actually stop the patrol. No. Say the brain instance is running. Okay, so brain, that's kind of in the wrong place. I'm gonna put that there. I'm gonna put that there. So I'm going to do on tick, and then we want an on tick. That means that this behavior instance can have an on tick now if it wants to. And then we need to get the current node out of the brain. So, fine. If not current node, return fail. If there is a current node, there. So which one? We want find node. Brain node actually have an ID. It does. And that's just return nodes.find node ID. So this is just find node if there's not a current node, we'll fail it. If we do have a current node, what do we want to do? So I think here we want to do that, and then we want to say current node ID is 0. Say if current node ID equals 0, current node ID is equal to the current root node ID. I think we want set, like we want to set current node, I think. We want to do, and then we want to do set current node can return optref brain node. And then node. So we want to do get game events, send node events. So send the events when we set it, return the node. See if was it all true? Every condition true. So we get the node. If every condition is true on the node, we set it to the current node and then we send the events. And then we return the node. And then move again. we do set current node, current root node ID. Okay. So we're going to say if current node is root brain node, if it's a root node, we need to immediately go to the child, the first child. So we want optref brain node set first valid child node parent node ID. If node for auto child index in node children. So I think we'll find node by index. So if there's a child, right? Set current node. So if the parent if the parent is a sequence or a selector, it might want a random index. So if node is selector as a behavior selector sequence type. Okay, so the behavior sequence. Okay, so we'll say if it's a behavior selector, so what we want is try unwrap. We want, what was it called? It's a sequence type, sequence type. Consecutive. So if the sequence is random, we need to kind of keep track of we always need to keep track of what nodes actually. Behavior sequence. So I'm going to say if sequence type is equal to consecutive, sequence type is equal to random. So the brain instance needs a array of Vue64 visited nodes, right? And when we call begin, we just say visited nodes empty. And when we go set current node, going to say if visited nodes dot contains node ID, return ref brain node. Else, well, we just say visited nodes to add node ID. Okay, so if it's consecutive, it will come along and it will try and find the node value next. It will try and set the node. If it's been visited before, it won't set it. So that will make sure that it goes linearly through the nodes. If it's a sequence, if the sequence type is random, then we need to go auto child index equals BM dynamic random. Between 0 and node children count. -1. So we need to say actually if node children get count, I'm going to say auto child count equals node children count. If child count is equal to 0, child count -1. So what we need to do is do it at least 4 times. No. So how do we make sure we pick a child? So I think we need a T array, size T, children. And we'll set that to child count, right? So we need to go for each child. I'm going to say if we find the child if not visited nodes contains child ID, valid children dot add makes me, maybe may as well do it by ID, child ID. I have to say if valid children auto index equals BM dynamic random between 0 valid children get count -1 just picked one. If set current node valid children index Now then, we can't just set it. We need to shuffle them and go through them. Does this work? Okay. So this is behavior. I don't think we need to do that. So I think begin does that. Begin will set the current node. Okay, so begin we'll do this. So we need to say find node root node ID. So if node and node is behavior root. If not node or not node is behavior root, return So we set the current node to behavior node, and then we just do set first valid child node root node ID. Just get engine events. Okay, so let's see what happens here. I'm gonna go make a coffee while this is building. I'm back in 2 minutes. Have a good break. All right. So all right, okay, cool. I just have a break when I need coffee, when my coffee goes cold or it runs out. All right. So let's see what happens here then. So we've emptied the visited node, set the state to unknown, we find the node. It's a root node. So we set it, and then we set the current node. If every condition is true, set to be the current node. And we send the events. So I think that needs to be the other way around. So if we couldn't set it, return. Set the current node. Couldn't find it. Node ID is 0, so that's wrong. What's that? So we set it. Send all the events for that node. Then we call onBegin, and then we're going to set the first valid child node. So what I might do is I might say if not node, return optref brain node. Get rid of that. So that's one child, and it's not a sequence or a selector. Because it's a root node. All right. So we've set it to be the current node to be 8804. Which is this one? Which is a sequence node. Okay. So set current node here now. We need the node needs to send the begin event or on enter or something. On enter, tick, and on exit, maybe. So we need to go for each type. behavior types. So I'm going to go using T standard mode try and wrap T. Let me want to do some like data. Enter. Okay, so that's in game brains that. So these behaviors. So we'll have leave. Now I might need to pass parameters, maybe. Just to know what brain it's at. Const brain. Maybe. Or brain state or something. Maybe not. Maybe not. So maybe we do if auto action equals node try and wrap behavior action. Or we have the different types of actions here. Using T, standard decay, T, decal type. And then we need a concept for action has on enter. And then we want const brain instance. I think we want that. And then we probably want to return E behavior state. Maybe that. So we say if const expr behavior action is on enter, if auto data say if we need to find out where to put the on leave. So that's called tick tick. That's wrong. Tick. So we want E behavior state on enter, const brain instance brain. Return E behavior state fail. E behavior state on tick brain instance brain, and then E behavior state on leave. Maybe it should be unknown. No. Okay, so set current node. If it's an action node, it calls on enter on it. So let's just run through this. So I think I'm going to say else if current node is a behavior sequence. I'll do selector first. We need to do this select. We need to set first valid child node. Or current node is behavior sequence. Else, if current node is behavior action, we need to go through all the actions. This is tick. So that's unknown if it gets there. State is equal to E behavior state fail success. So the running are unknown. So if it's a fail or a success, so we don't know the parent node, I don't think. Okay, so we need to actually find parent node. Ooh. Or you just pass it along. Default brain generator. So we're going to say brain node will have U64 parent in it. Here we'll do brain upwards. Let's just child index. Basic brain nodes. I'm gonna have to go through. Ooh. Need to add all the nodes in first. And in brain nodes. I'll see in brain nodes and children. So actually we could do this. Brain nodes C parent is N. I think that'll work. So that means we need to rebuild the brains. Brain groups. And the behavior controller now. Okay, so let's just run this. So if we succeed or fail on an action node, we need to go to the parent node and fix these. So I need to do struct brain instance. What's the problem? Where's eBehavior state? That's on a different one. In a different file. So, yeah, if it has a success or a fail, it needs to go to its parent node. And then if its parent node is a sequence and the result was success, you need to go to the next one. If it was a selector and the result was success, you go back up the tree again. Does the brain instance have a state? It does have a state. State's the kind of wrong name for that. This is going to cause shadowing problems. It needs to be instance state or something. Behavior state. So we're going to rename that behavior state. So much stuff called state. Right. Whoops. So this is unknown, right? So I think actually we just say behavior equals unknown. And we get rid of state. And this is behavior state. So maybe we do behavior state. It's unknown. And that will just return. Return. We tick it. This might tick even if it fails. So I think this goes like that. That goes like that. Then we set the behavior state. And then This just returns the behavior state. Okay. So begin. So we set the first valid child node. Let me call tick. So the current node is a sequence node, right? So it's going to set the first valid child node. Sequence type is random. I'm going to try and set this node. And it's an action type. I'm going to call onEnter on the action, which is just going to return unknown, right? Okay, so this needs to be handled. So what happens if we return unknown? So this is the behavior state. Maybe onEnter doesn't. Well, it would be handy. So if we pass back unknown. Maybe this needs to be like an expected thing, which encodes the error as well. So I'll set it to unknown, right? But it will return. I have to say, if behavior state is not equal running dot reset, So the question is, do we remove it from visited nodes so we can try again later? See what happens there. I think we do behavior state. It's running. All right, yeah, no problem. Every condition is true. We set it to be running. The node is a root, right? This is random. So that sets it to unknown, right? So that means it resets. It removes it from there and it resets it. And then it tries again for the next one. Oh, what happened there? That was a selector node, was it? Ooh, that's kind of wrong. Oh. Okay. In child mode. Set it. That didn't work. Try again. Or is it just a select? Oh, it is a selector. So that didn't work right. It should have only gone to the. If it didn't work, it should have failed all the way up to the top, all the way. Yeah. So this fails. Oh, it's passed. Alright, so let's just have a breakpoint here. So that one failed. So because that one failed, we need to have whether it's we'll have that is unknown. What does unknown mean? Maybe unknown and fail are the same. Maybe that's what I need to do there. Where is that? Behavior controller. Maybe fail goes there. And there's no such thing as unknown. So we tick the behavior state. So what's this on? Tick. So we don't do that there. Say if behavior state is not running, we do something here. So this is where we're going through the valid children. If we didn't set it, we need to it depends on what type of node it is. So we didn't set it, right? The thing is, if it fails, do we want to come back again and try? Next frame, you know. Don't know really. So maybe do. So if it equals fail, so if it's not running, so I'm going to say if behavior state equals fail, we remove it so we can try again next time. You have to experiment with that. Okay. So we also want to track the begin. So current state is fail at the moment. Set it to be running. What type of node is this? Running. So if this comes back as a fail, do say we're going to allow to visit it again. Maybe. So it bailed out on a fail. $804. So I have to say if the node is a sequence node or a selector node, behavior selector, then we continue. Else, if the node is behavior sequence, then we break. So pick the selector first, that's because it's random, isn't it? So it's a sequence, so we break. Because the sequence was broken. So if that doesn't work, we need to go back to the parent. So we need to go and find the parent. Interesting. So I'm getting back up to the root now. So I just think we don't actually do that. We just do current node ID, parent node ID, parent ID. So the current node ID is that. So we're going to return fail, right? Which is correct in this situation. Alright, so the next time we tick it, what do we do? We try again. Okay. So I think here we're just going to say it's a behavior root. Okay. Yeah, right. Turns fail. Next time around. So it's saying that we visited this node before, which we have. Yeah, cup of tea would be lovely, thank you. There you go. Thanks, Dad. Try that. Do we need visited nodes? I think we do. For when we want to select the next. Again. This time we pick the selector node. So we tried from the top of the tree again, and we picked a different node because it's random. Behavior state is running. Oops. Current node is this selector node. So we want to find the first valid child node of this selector node. Also random. That failed. So we're going to try the next node. Oh, thank you very much. Cheers. The current node is a root node. We've set it to the sequence node again. So this time we're going to return the selector node. So what does the selector node do? So this is an action node. So it's a selector, so it tries the next one, which is also an action node. That action node doesn't fire because there's nothing in it. Fail. So that node tree, I think, is working. go to its parent, which is that sequence node. And the next time we come along, current node is the sequence node. That returns fail. So the next time we come along now, this is the root node again. It tries it all over again. I believe that's working. Complicated. Oh, we have a problem there with the animation though. That might have been. Because we had the game paused for so long. What's going on there? So that's something to do with okay, so that's the patrol. So what is going on there with her animation? Getting caught here sometimes, yes. So it's running when you're evaluating a sequence or a selector. So a tick sometimes leaves it running. Oops. So this is running because the current node is a sequence node. So it's kind of always got to go to an action. gets to here. If it does set, so if it's a behavior or a selector, we do that. Else if it's an action. So this might set it to be an action. I'm going to say if current node ID is not equal to current node ID, current node equals node current node ID. In this case, it's a selector. Yes, that doesn't work. Could make it recursive. I could just do tick again. I'm trying to avoid that though. Okay. So that should fix that animation bug. Yeah. So the question is, that can be an else. Now, if it's an action, let me just tick it and return the behavior state. Bossy, how's it going? Hope you're alright. Just getting to the end of this behavior, NPC behavior stuff now. Hope you're having a good day. Okay, so what we need to do is the test action. On enter just needs to return running, right? And then we'll just do like float t equals 0. So on enter there, say t equals 0. And then on tick, we'll just say t plus equals dt. If t is greater than 1, return success, else return running. Unable to code again. Oh yeah, man. With big refactors, it can take ages, can't it? Been there. Oh yes. So they should tick for 1 second. Well, actually, let's do it a different way so we can debug this easier. Let's make this a U32 and just do t++. Let's say if t is greater than 1. Oh yeah. So what I do for refactoring like that, don't know, are you in C++? This might work for other languages. In Visual Studio, if you press Control F7, just builds that one CPP file. So you can just stick to fixing all the errors in one CPP file. And then you can press like, you can build again, find the next CPP file with all the errors in, and then Control and F7 that one. And then you can do it one file at a time, and I find that's a little bit faster. So let's just have a look then what this does once it's finished building. Alright, yeah, maybe there is, and if you can bind it to a hotkey, that would be great as well. It also helps with development time in general, because if you're just working in one C++ file but you've changed a header somewhere, you can still just work in that C++ file by just compiling that C++ file to check that the syntax is compiling properly, and then at the end you can do a compile. We changed stuff, yeah. We need to actually rebuild the brains. Neovim, yeah, that's right, yeah. Yeah, we did. Okay, so we're going to say that this one is running now. I'm going to set that to be the current node. Is it? Yeah, I need to try out something like that. The thing is, the debugger, like, is, I don't really, my style is not write code and then debug later. It's all that happens at the same time. So it'd be difficult for me to have a separate debugger. Let's try that again. Yeah, people say that it's really fast. I mean, I don't really mind. I don't really find it that slow, personally. Yeah, I mean, I'll definitely look at it. Like I said, just because I don't really, the style that I have is not separate debugger to text editor. I don't want to have to keep swapping IDEs to debug. Yeah, nice one. All right, so that's running now. So the current node is the action. So if there's a current node and current node is behavior, this basically. Then we want to do the recursive tick. I want to try and take out that recursive tick. Okay, we can't do that then. Else to do that again. And maybe we can do a recursive tick. So it will just tick the action. Let's try that. I do have assert, yeah. I don't often use it though. I used to use them more. But believe it or not, I've started using like standard optional. And I wrote this thing called Optref. Optref, which is standard optional for pointers. And asserts just kind of went away. Like I didn't need them anymore. But I do assert sometimes. If a state absolutely has to be like guaranteed. But yeah, I do like assertions. Okay. So it is gonna do the recursive tick, but it's an action. So it's gonna call tick on the action. It's gonna return running. Which is correct, that's what we want. Oh, didn't want to do it like that though. We wanted a breakpoint there. Have a look at this overlay. They look fine on my chat screen in Streamlabs, so it's all right. Oh yeah, it's like escape to them, hasn't it? Probably to stop you typing HTML into it. But yeah, I can read it here. Any reason for not using one from CAssert? So I don't like the idea that it pops up. I don't like that it pops up the message box, and then when you click a button to stop the program, and then when you stop the program, the stack frame's not where the assert was. So if I do like VM assert false like that to fight that assert, the program crashes right there on that line. Whereas if you use the built-in assert, it's just a debug break. Wherever it is. If you build in the assert, if you use the built-in assert or the assert from the library, crashes like a few stack frames in. So not a fan of that really. And I don't like the noise, it makes a noise. So if I put that there, I have to delete some of these breakpoints. Oh, it didn't even get that code, didn't even get there. Definitely gets here. Yeah. So yeah, it crashes right there, you see, on the assert. And then I have another macro. I have a few. Assert on the main thread. So that'll crash if you're not on the main thread. And then I have assert message or something. Oh yeah, so assert's multi-parameter, so you can do like, you can actually type a message like, what? So if you're really like, so I do have assert on array indexing. Have here, look, array index out of bounds. So if it crashes there, I immediately know it causes the array index out of bounds, and I don't have to look at what file I'm in or what class I'm in or anything. So you can put a message, which I quite like. Obviously you do want to assert if your array index is out of bounds, because that is a undefined behavior. Yeah, BM assert, it's a macro, it's just this little line here. So if not condition, debug break, which is just debug break, which is just a Visual Studio, you know, debug breakpoint thing. It's a code breakpoint. So you can either set a breakpoint by doing this, or you can set a breakpoint in code by doing that. I don't even know if you need to do the brackets actually, but that, yeah. And then assert main thread. So assert main thread's useful if you want to only access that function on the main thread. So it just does a normal assert with is main thread, which that's a Windows call. Get current thread ID is the main thread. Like sometimes you don't want functions to be executed on anything but the main thread. Okay, so just follow this through then. So it should have 2 frames of running this action. And then it should return success. So we've gone 3 stack frames in, which is unfortunate. I need to get rid of that recursion really. Okay, so it's going to tick. And the next frame does the tick. And that's returning success. The success needs to do something. Yeah, that's right. But also standard vector has an assert, I'm pretty sure as well. Or it'll throw, depending on what type of compile options you've got. So yeah. You know, it's a good place for an assert is array out of bounds, index out of bounds, because it's definitely an error. Whereas you do something like if you assert that a if I was to assert that this like function returns success or something, it's not really an error as such that it's worth crashing over. Yeah, exactly, yeah. Because the program would continue to run without a doubt. If you didn't assert it, it wouldn't crash, but it wouldn't crash with a seg fault. Seg fault or anything. It would continue to run until it crashed, and it would be undefined. So if this returns success or fail, it's the same on enter. With behavior state, well, if behavior state is equal to success if it's not running, then we need to set the parent again. Current node ID. So parent find node by index. Current node ID equals parent ID. So where do we do this somewhere else? Where do we do this? But we took it out. It's here. Right then. Let's try that. Why do you use custom types for things? Strings. So it's all about memory allocation, really. Like, got my own allocators for things. Now you can't use your own allocators in standard string, so you could do that, but I just wrote my own one a long time ago. So I've got string, which is basically the same as standard string, but it uses the engine's heap, right, rather than new or delete. It doesn't use new or delete. Like standard string will use new and delete. This uses a custom heap. And then W string, which is standard W string, which is the same reason, because it uses a custom heap. And then I've got T string, which is the same as string, except it uses a different memory allocator. It uses like a stack allocator, which is much faster than a heap allocator. The downside of that is that the memory is only alive until the end of the frame or the end of the next frame. So if you want something quick, if you want to like format a string to just use there and then to send to the output window or something, T-string's really good because it'll be really fast. And that'll be faster than like all of these. And then of course TW string as well. But you could, if you wanted, extend these, I suppose, with custom allocators. Which maybe I would do if I was to write it all again. I'm not sure, I'll have to look at it. Yeah, there's different ways to convert. So if you do convert string, ABC, I think that's how you do it. I think it's something like that. Break time, nice one. Can't remember. I don't. Oh, it converts from a string to a W string. That. I can't remember how this even works. I haven't done it for a long time. To type. Use that. That's it. I've got on the API. I've never used them really. I always use the wide ones. Yeah, that's right, yeah. I'm not sure if you can do it to standard string. No. But you could extend it to do that. To go to and from standard string and stuff. And then I like rename the types. So I have like U32. Instead of unsigned in, just because it's quicker to type and it's easy to just see how big the type is. Yeah, the encodings, yeah, exactly. This stuff. Yeah. That's Windows. Like random jumble of letters _s. Yeah, it's mental, innit? clearly designed to just be wrapped, you know, I think, and stop name collision. Yeah, I've got something like that as well. I can't remember. How do I do that? All this stuff. Get UTF to W straight buffer size. I mean, that's crazy, isn't it? I mean, that's my name. This code was written a long time ago. This is like the Windows wrapper, I think, very much. Yeah, there might be a standard one. Those underscore S ones are Windows only, I think. Alright, okay. I haven't looked at this for years, so I'm not really sure if there are anything new now. Yeah, the underscore S will check for buffer overrun. So it'll make sure that you don't write over the end of your string and stuff when you're converting. Underscore safe, probably. That's what they were going for. Whereas the standard, the C versions expect, you know, the data that you pass to them, you know, the buffer to be big enough. Yeah, meaning safety, yeah. Yeah, sprint fs. Yeah. Do I have that? No, that's not me. That's STB image, right? It's a different library, that. I don't use that one though. Do I use it? Do I even use sprintf? No, I don't. I think I'm using standard format everywhere. Well, not standard format. I piggybacked off standard format. I have helpers format string like that. Then you can do like 2. Rather than have to put like %d there, you know. You can just use these curly braces for everything. Yeah, it's more or less the same thing. No, yeah. I mean, it's where do you put stuff that doesn't have a proper home, you know? There's quite a lot of string stuff in here, actually. Build string, arrays, substring instances, format, different string types, tokenization, split string on lines to array, split strings to array, string ends with starts with. It's just string stuff actually, so maybe it should be called string helpers. Yeah. That's very old, that code though, so if I was to sit down and write strings today, I might do it different, I don't know. Or I might use standard string and then work out how to use the custom heap. So I definitely want to use a custom heap for memory allocation, because then I can track my own fragmentation and how many pages I'm allocating and all that stuff. Converters, yeah, cool. Right. Okay. If I could get rid of that, this would be great. I don't want it to be recursive, really. So we're running. Ticking. And then return success. We find the parent node. And we set the current node ID to be success. Now, next time we come down, we're back on the selector. Yeah. I have a color class. Yeah, I've got a color class. Call it float color. I was thinking about changing the name to just color actually. It's just a bunch of stuff. So, you know, you can go from a float. So you can do like auto color is like float color from hex to like you, so they're like web colors or whatever, or you can just set RGB. Or then I do have an image. The image class is pretty substantial actually. There's a lot of stuff. So there's an image which is on the heap again, and then there's TImage which is on the temporary stack thing. So if you just want you want an image, then you just want to allocate the memory on a stack. But the image can do tons of stuff. It can do like all sorts of compression and all sorts of like I have like image generators and stuff that can do things like create Perlin noise and do flood fills and all that stuff. Create depth, what they call them, distance fields. It's a pretty big system, the image. But if you just want to load an image, it's hello.bsd or something, and that will load an image, a Photoshop file, or PNG or whatever. If you wanted to generate like a 4K purling noise texture, tileable purling noise texture, how would you do that? Generate tileable purling image generator. I can't remember. So you'd set like width, height, channel count there, and then you'd set frequency, octaves, size there, and it would generate purling noise in that image. Color byte, color float, color hex. Yeah, cool. Yeah, I've just stuck with float colors at the moment, and then I can convert to like an integer with it. So I could do int float color to int. Fill in rectangles of a given size. Yeah, cool. Yeah. Yeah, so you can do it. You can fill, I think. im.fill. All right. Draw rect. So you can draw a rectangle and fill it with stuff. Or draw a rect outline. Draw a rectangle outline. You can save it. So you can do write to file or write to memory. And then you pass a writer, so like a BMP writer. Is there a BMP image writer class? And then the file name. Oh, you know, like TGA image writer. Save it as a TGA file. Yeah, save. So it's because you can have write to file and write to memory. That's why I've chosen a bit longer name. You can do im.write to memory. Like that. So you could write it to so you could do something like buffer. Probably has to be a push buffer actually. Write to memory TJ image writer buffer, and it will push all the image data into that buffer. Yeah, it's good, the image class. It's one of the best parts of the engine, I think. At least the support libraries of the engine. The image stuff, it was just me. I've written a bunch of different ones, and it's just like each one gets better than the next. Yeah, I mean, if you end up with similarities, it means you probably hit up on a good design. For sure. Like, the image does use some libraries. So so you can do write to file, DDS, image writer, BC7. How does this work? So you could do image write to memory, DDS image writer, BC7 encoder. So that will write a DDS file with BC7 encoding. And the BC7 encoder is a library, ISPC. So it's not all written by me, but the actual API is mine. File system stuff, yeah. Yeah, cool. I have file stuff as well. How does it work though? The asset compiler will load some files. Run. Asset compiler worker. There you go. W recursive file iterator into array. So that will like so this is old as well because I would have put that the other way around. I've had the path and then the array. But whatever. So you would do W recursive. Is that what it was? Into array, and then some array to put all your files, and then the path, and then it would put everything into that array, all the file name. Well, it's not file names, it's file paths, and the paths have different, have the name and they also have like the write time and everything, but recursively for the entire hard drive. Cool, yeah. So standard unique point folder. See if I can. How do you read just a folder? Directory iterator. Maybe. Directory iterator into array. And the array you want all the directories to go into. And the path to the directory. So I added it this way. And that returns whether it succeeded or not. So you could say this. So what would it be? Something like that. So rather than get it to return a unique pointer to the path, it makes sure that the memory allocation stays on my side of the API. Do you know what I mean? So then there's nothing to free. I mean, you free these paths, but it's on my side of the API rather than nothing's allocated in there and pass back. Well, loads of people do it your way as well. I don't think there's really anything wrong with it. I think it's style. Yeah, it's really good. Like, I think kind of coming up with good APIs is one of the more challenging parts of programming. I think when people are new to programming, they're just concentrating on the syntax and getting the syntax right. And then later you kind of want to get the API right as well. So Spine, which is an animation library I use, it returns. How does this even work? I can't remember how it works, but I remember the API does return me just a raw pointer back, and then it's not documented how to get rid of it. So you don't really know what to do with it. It's fine if the pointer needs to be around for the entire length of the life of the application, but that's not the case here. Like, I need to be able to get rid of animations if I need to. You know, if I need to like restart the game from in the editor or something, I need to actually deallocate all of the animations. And I think if you're writing your own containers, that's a really good way to get really good at programming and frameworks. That's one of the reasons, I suppose, why I would rewrote String, is just to become better at programming with strings and stuff. This is several years old, this now. But at the time I was like, I'll try and write my own string class and get better. That's why game engines are good, because you get to do tons of stuff. There's everything really that you could ever want to do in a game engine. So this actually has to call tick there as well. This is recursive in two places for this to work now. Yeah, try writing a dynamic array. That's always a good place to start. And then a hash table. You know, and a stack and a memory pool and a heap and all those traditional computer science things. I bet there are tons of professional programmers out there who don't know how to write a heap, but they call new all the time. What's TDD? Yeah, I mean, you don't really need... I mean, it depends on your application. I like a custom heap for a game engine because then you can actually look at the fragmentation of the heap. You can actually control a little bit more tightly what memory you use and how it gets worked. Oh, test-driven development. Okay, yeah. Yeah, that would be a good test-driven development case, I think. Writing some container stuff. A heap is one of the more complicated ones. There's a couple of different types of heaps that I have. This is the global heap, right? So this is my equivalent of what new would use and delete. It's not very big. It's only well, it's 400 lines, but there's lots of like debuggy stuff to check that the heap doesn't get corrupted as well. If you were to just ignore all that, it's not big. And then there's a DirectX heap as well. Which has got more stuff to do with buffers and textures. And it uses the DirectX API. But I'm pretty sure they work a similar way. So there you go, like heap allocate, and you give some bytes. So you want to allocate a megabyte, and then it returns a heap region. So on a traditional heap, you return void pointer, void star, but in direct it needs to be a heap region because it's got ties into the API. But the global heap, wherever that is. Yeah, if you call malloc, it returns a pointer to an unsigned character. Yeah, test-driven development's good for certain things and not good for other things. It's good. I use it for a lot of that image stuff has got tests as well to make sure that the compression's working. So it will do stuff like I'll have tests where it would take a photograph, compress it with the BC7 encoder and write it to disk, and then I can just look to check that it's actually written the image properly. Custom heap for DirectX. So in DirectX 12, I think you need one. You need some kind of memory allocation system to write textures to give textures to the driver and buffers to the driver. And it's a little bit more complicated because it needs to sync with the graphics card as well. So the idea is you create a heap and then you get a little bit of the heap and you put texture, you write a texture to it, and then you tell DirectX like, look, this texture's here, and then DirectX, the driver, will pick that back up again and copy it down to the GPU. So you have to sync with that copy and make sure you don't delete that region while the GPU is copying it over. So it's a little bit more complicated than just a normal heap. Yeah, cool. Not heard of Reshade. I'll take that. I'll take a look at that. Did you write the tests first or the code? I wrote it together, so I knew what I wanted to do. I knew I wanted to compress to DDS like BC7 and BC4. There's a few different compressions. So I was like, well, I will just write little tests for that. Let's see if I can see if they even pass. I'll just try and find them. So this is the solution for the libbm. So this is the support library for the engine. And then if I've Test Explorer, build your solution. So this Test Explorer has a bunch of tests, I think. Well, it's not showing them. Oh, it's because I've unloaded it. Here we go. Oh, there's a bunch of compile errors. There are tests though, look, compressor tests. Part of it was to do the tests and part of it was just to learn about this test driven development stuff. Splitting strings, image tests. I'm not strict with my source control at all. I don't even write messages. So if I want to check in, I just write, I think I just write X in the messages. I'm terrible. I think there's only me working on it, so it's okay. If there was more than one programmer, it might make a bit more sense to write messages. But I don't. I'm terrible, yeah. Okay. Yeah, so we've got another. Yeah, that'd be great, thank you. So what's the difference between all those different types of commits? I don't know anything about that, really. Red commit, green commit. Red commit, is like red commit doesn't compile and green commit does compile. I don't know. Yeah, let me know what it is and I'll give my opinion, that's fine. So it's going to tick again. Success. So if it's, and it wants to tick again. So what's behavior state? Fail. I see. Yeah. There's no harm in learning all that stuff. If you're a solo dev, I'm not sure. Well, if you're a solo dev making stuff that only you're gonna use, it's probably not that useful. But if you're If you wanted to learn about it, then that's great. If you're making libraries that other people use, it's probably very good to have this bit of the code is failing information, because then if they come up against that failure, they can just check that the developer already knows about it and they don't have to submit any kind of bug report. If you're just on your own making stuff for yourself, I mean, it depends if it'll help you, I suppose. All I do is I keep a list of bugs. So if something was to say fail a test, I'd write it in there. And then I know that in the future I have to come back and fix it. Yeah, that's. I think everyone does that, and it's kind of cool to, discover something new, and then just try it out and see where it is good and where it is not. I think that's good. I don't think there's any harm in that. As long as some people get very dogmatic about it, and I think that's the bad way to go, Everything has pros and cons. And you become a good programmer when you actually learn the pros and cons, not the design pattern itself, or the language itself, or whatever. It's when you learn about the pros and cons and when not to use it. If someone knows 1,000 design patterns, doesn't know when and where to use them, I wouldn't rate them very highly as a programmer. But if you know like 5 and exactly where to use them, you'd be a lot better programmer. Thank you. Got a cup of tea. Awesome. Fear the man who has practiced 10,000 kicks once. Yeah, exactly. And it also says something about the person that they'd rather learn 10,000 design patterns over how to use the design patterns properly. Because it's like they want the big number or whatever. They want to show off that they have the big number. My advice is learn it all. Some people like object-oriented programming, some people hate it, but still learn it and decide if you like it or not later. Hopefully you like bits of it and you take bits away. But don't learn it and then be dogmatic about how good it is. Alright, yeah. I do think object-oriented programming is a good way to learn programming. I think people need to be able to visualize it, the program, especially when they're starting out. Need to be able to visualize it in their mind so they can attempt to solve the problem. An object-oriented program is kind of designed for that. You can still write objects in C as well. thing about C++ is it's part of the syntax. But yeah, it's like I have classes and things for encapsulation. I don't tend to be overly hierarchical or polymorphic or anything like that. Sometimes, like I've inherited there, but that's not inherited any polymorphic behavior. That's just appended onto the end of the brain class. Don't want to use struct as a class. Yeah, I mean, whether you use struct or class is it depends on your own style as a programmer. So one's kind of, there isn't one better than the other, it's a style thing. So some people use structures just to store flat data, which is fine, and they don't want to put these methods inside. And then they'll use classes for the public and private and the methods and all that. What I tend to do is I have classes for outwardly facing API. So if this is designed to be used by other systems in the engine, whereas this is not. So it quickly allows me to see what I want publicly exposed to the rest of the engine and what I don't. Now, of course, like anything in the engine could use a brain instance if it wants, but the intention is that if you want to do something, try and do it through the controller instead. So I use struct, I separate struct and class that way. That's a personal, it's just a style thing. So the controllers are all classes because the idea behind a controller is it's meant to be the public. If you want to actually do something with behaviors, use the controller. And it also helps because the controller will use these structures, and because the intention is for them to just be used by the controller, because that's the intention. I don't have to write getters and setters everywhere, which saves a lot of time. But I don't just put it in the CPP. I include it in the header file just because you might want to. It's not like compulsory, you can't use these outside of the system or anything. So I do include them in the header file. And some of them need to be in the header file, like these things. Yeah, good idea. Yeah, I don't actually have it. So I always tend to put constructors at the top. That's really it. I'll probably group operators together somewhere. And then I put I put fields in the bottom most of the time. And methods in the middle. And then I might group the operators together. And then a lot of the time I'm doing that as well. Like making columns. And that's mostly because when I have another file, it keeps it there, If I have another file on the other half of the screen, I can still see the entire the entire function signature, you know. And then you do something for long enough and you just get used to looking at it like that. Oh. I think the behavior tree now is kind of working. It's working even though it's not, I haven't tested, properly tested it. So there's some improvements, like I should get rid of the recursive. It's not really neat. It's not really a problem though. Then I actually do need to write a pretty substantial test case for this because it's quite complicated. Right, we're back in 2 minutes. I'm just going to nip to the toilet. We'll be back soon. Alright, I'm back. Okay, so what I might do, let's just run through this one more time. So this ticks and it says it's still running, so it comes back next frame and we succeed. If it's not running, we find the parent and we set it, and then we call tick again with the parent node, which is the selector. Then it tries to set the first available child, which doesn't have anything associated with it, so it cannot set because it doesn't have any actions associated with it. So it fails it. Do we want to fail it if that happens? I think if it doesn't have an action associated, it has to fail. And it removes it. Because it's a selector, it goes on to try and do the next one. There isn't one. So it gets the parent, sets it, and then it returns fail. Which I think is the correct thing to do in that situation. Alright, so let's just write another action. We need to do the on leave. I mean, we might. Ugh. We won't. Well. When can we do on leave? So we're going to say if behavior state is not equal to running. So we're going to go if constexpr behavior action has on leave. Data on leave. This. Now, maybe that should return void. You can't, it doesn't make sense for it to be returning running or anything. Right, that'll call the on leave. And then we're going to put on, oh, we got a compiler. What's the problem with that? Oh, it's not a function. Okay, so we'll make a new action. Call it test action 2. So we need all those things. This is test action 2. Build that. And then we'll open the editor up. And we'll add test action 2 to the node that doesn't have anything in it. Oh, wait, I'm going to get a link error actually. Need to actually implement them. All right. Test action 2. Oh, we need the draw for the. We need that as well. Bit in the wrong file there. So what is it? Canvas, draw. If I've written this system right, we can just add a test action 2 onto the node graph now. Vossi, if you're still there, learning C would be good because almost all of C works in C++ as well, so you'll be able to kind of do a hybrid of both. It means you'll be able to drop some of the C++ things that you don't like and drop some of the C things you don't like and replace them with the other. Like some people like mostly C, but then they'll compile into C++ so they can use operator overloading and function overloading. Some people like that. And then almost everything else is C. So you can pick and choose. Alright, so we don't want to do this because... So what's interesting there is... It's turning like... And then it's failing. It's running for a while, then it's failing, then it's running, then it's failing. That's why that animation looks really weird. Anyway. Let's look at the brain. So now on this last one now, we can put in the test action 2, set bacon. Save that. So let's just watch this node graph again. So we may as well keep watching what happens from the beginning. So current new root is the node roots. So we set the first valid child. So it sets it to that node, returns the child. So the child node is the sequence node. So we want to set the first valid child of the sequence node, which is random. So it's set the selector node. So we want to set the first valid child of the selector node. Sequence type is random again. So this is this action node. So we're going to call onEnter. All right, yeah. No. Oh, lovely. Have a great time. It's all right. It's all right. See ya. Okay, so we're running this action node, the test action node now. Okay, so we're going to take this test action node. So we're in the running state. So next time I come along, I'm going to tick it again. So we complete, then we call onLeave, which doesn't do anything. And then we find the parent, which is the back to the selector node. And then I'm going to set the first valid child. There's only one valid child left. So I'm going to try and set this. So now we're selecting test action 2. And then we're going to tick test action 2. We're running test action 2 now. Behavior state running. And the next time we come, current node is the action node. So I'm going to tick it, and that's going to return that it succeeded. And then I'm going to call onLeave. And then we're going to go back up to the selector node. I'm going to try and set a valid child. There isn't any left now. So it couldn't do it. So it finds the parent node and returns fail. Yeah, so when it finds the parent node, it needs to call tick there. I think return tick there as well. All right, go through that again then. So on a sequence node, so we're going to set the first child, which is random. So we enter that. We return the child. I'm going to tick. So we tick the action node. And then when we come back again, still in this action node, so we tick it, we leave, then we go to the parent, it's the selector, so we set the first child node, so we're running now. First child node, I'm going to tick it. So now we're running. We're running the second action. So we're going to come through again for this action. So this action will finish. Call on leave. Get the parent, tick it. Couldn't set the child. So it gets it again, ticks it again. So we're back in the sequence now. Okay. Oh, was that? Let's start again. All right. So the current node is the selector. So we can tick the action. We're going to tick the action again and it's going to leave. But it was a selector. And the behavior state was success. Okay, so that's actually incorrect. That's actually incorrect. So the parent is a sequence there. So we do go on to the next one if the parent is a sequence. Current node now is a selector. So the parent is a selector. The behavior state is success. So we have to say parent is behavior selector. And behavior state equals success. Well, if it's a sequence, let me tick again. Else parent. Well, if it's a sequence, say if behavior state success, let me tick again. Else if parent is behavior selector, if behavior state equals fail, return tick. Okay, let's try that. Okay. So the current node is a sequence. So we're going to tick with the sequence node. So the parent is a selector and the current state with success. So we don't tick. So success. Should it have gone back up to the sequence though? I think what we might do is just load. Oops. We won't make them random. It's just confusing things. Well, I've actually implemented the case where it's not random though. It's just that. So the sequence is going to be consecutive and the selector is going to be consecutive. Okay. I'm in the wrong place here. So Jenny's not moving, which is a good sign. She shouldn't be moving if the behavior is taking control of the movement. CodeRad Games, thanks for the follow. Got any questions? Just ask, no problem. All right. How's it going? Yeah, great. Working on NPC behavior trees. It's the first go at it, really. I might come back tomorrow and I'll rewrite this. It's getting a little bit complicated. Okay, so we did set the first child node, which is an action node. Oh, hang on, we need to set up some more breakpoints. Here. You do a bit of coding as well. Take it by a username, maybe. So first child node. Okay. So the current node is a sequence. So sequence type is consecutive. Action. Just a bit cool, man. I love talking about programming. Talk about it all day. So we're running this one now. So it comes back as running. Now we succeed. Call on leave. If we're not running, we find the parent. The parent is a sequence and it was success, so we tick again. C++ favorite language. Yeah, I love C# as well. I've done quite a bit in bit of stuff in C#. Not games really. I did a little bit of Unity a few years ago, just trying the engine out. I've written like till software in C# and website. Well, not so like applications that interface with websites to like add products onto them and stuff like that. But not game stuff. But yeah, I like it. C#'s great. Yeah, man. But yeah, doing the engine in C++ because I don't know. I think C++ is. I prefer to spend all day in that than C#. I don't know. Okay. So we're back on the sequence. So it couldn't set oh, hang on. We need to actually change this. If visited nodes contains child ID. Continue. Oh man, it's good that he gave it a good go though. Yeah, nice one. Takes a lot, doesn't it? There's a lot to it. Yeah. SDL OpenGL, there, nice one. This one's well, there's no like front end, it's just Windows, and then the back end's DirectX 12. At the back end of the renderer. Yeah, man. Okay. Set current node. So we're going to tick this now as an action. Weirdo the Farmer. That's a cool username. Unity for the last 4 years. Yeah, I like Unity. It's good. And there are some, I mean, Pillars of Eternity was made in Unity, so that's all you need to know, really, innit? Like an awesome game. Yeah, if you've got any questions, Weirdo the Farmer, no problem. All right. So we're running. And then I'm going to tick and leave. So they get the parent, which is the sequence, was successful. So we need to tick again. And then we set that one. Yeah, this is working now. Purpose to making a custom engine. It's challenging. There's a lot to it. And if you want like a challenging and you want to write an application that covers a lot of different things, like, you know, there's like everything in an engine basically. It's like good to do. Become like improve your programming. If you like if your goal is to make games, just to make games, then you can of course make your own engine, but obviously you could use Unity and stuff. But there's making games and there's making games technology. If you want to learn how to make games technology, then writing an engine or part of an engine is a good way to learn about that. Because of course making the engine and making the game with the engine are two different projects really. I mean, it won't harm you to know how an engine might work. It's a big time sink. I mean, if you're just trying to make games and you're not bothered, I suppose the key thing is, are you bothered about games technology? If you want to make games professionally yourself, like indie games, you kind of got to weigh it up. I mean, if you have no experience at all making game engines, then probably use Unity or Godot. There are other traps in using those engines, more business style traps though, like you're relying on a company in Silicon Valley or whatever for your games to even work. And right now Unity is free, and right now Godot has a good reputation. But you just don't, it's just a risk, isn't it? It's a business risk. Imagine you spend 15 years making awesome games and then Unity closes or decides to do something you don't agree with, and all of a sudden your games don't work. You kind of got it. If you're trying to be a professional game developer, you've got to think about those things as well. You've got to weigh it up. But my personal reason is because making game engines is awesome fun and it makes you a good programmer. Right. Is a plan for the engine to be made available to public? I don't know, really. Like, one of the things I don't want to fall into is having to maintain it for other people. So one of the, if you try to make it available for the public, you're all of a sudden kind of responsible for it, aren't you? If someone's trying to make a game with it and then you do something which breaks their game, you have to fix it. Which I don't really want to get into all that stuff. What I might do is, like, one day if I do something like a Patreon, I might like give access, I might like just give people the source code with no kind of like, I'm not suggesting people try and make a game with it. It's just like people are interested in that type of thing. Maybe, I don't know. Like, the engine's only 18 months old at the moment. It's not really mature enough to release at all. But in a couple of years, maybe. I'll never release it to make money or to maintain. I'll just release it for kind of like if people want to look at it. There's no point trying to make money because the other engines are already awesome. So one person sat making an engine is never going to be able to compete with Unity or Unreal or anything like that. Another good reason why I make my own engines is because you get to make exactly what you want. If you don't like the way that something works in another engine, you just don't implement it that way, you do it a different way. So this engine is not at all like Unity or Unreal or anything. Like, the editor is there just so you can take a high level look at things that you can't do in code. If you can't code, you can't make games with this engine, because I've made it for me who can code, To see a game called Noita? No, I didn't. Noita. Need for custom engines. Yeah, I mean, if we're talking about a need for custom engines. Oh yeah, nice. A concern I kind of have is if you're young and you want to get into games, making games, you might go straight to Unity or Unreal, like immediately. Even at university, the teaching, if you go to a university course on game development, they're probably going to do it in Unreal Engine or something, and you just go straight to that. And I worry about a brain drain of game technology. Whereas when I was at university, before these engines, well, Unreal was there, but it was private. You had to buy it. It wasn't an option, so you went to DirectX or OpenGL, you know, and you started at a lower level and you learnt that way. So it's two different types, like ways to make games. And then if in 20 years nobody even knows anything about game engine development, it's not going to be good for the industry. This game looks banging. Every pixel is a physics object. Wow, cool. Oh yeah, I can see. Yeah, I have seen this. Yeah, so whoever made this is absolutely amazing, obviously. And you know, one of the things is, I'm not saying it's real, but it is a coincidence that the game industry is suffering now, and there's lots of layoffs in the industry, and there's an astronomical rise in game companies using third-party engines. You know, maybe it puts the gamer off. I don't know. Yeah, no one makes their own OS. So that, yeah, obviously, so you probably won't be surprised, but loads of my friends who aren't particularly into computers, they think Windows is the computer. Do you know what I mean? They're the same thing. And I worry that people are going to think that, like, a game engine is Unreal Engine. You don't even know that you can make one yourself. Is this what I do for a living? Not really. I was in the industry a long time ago. I was in the industry in the Xbox 360 days for a bit, doing C++. But coding's always been like a creative thing rather than a career thing for me, I think. Like my actual job, I do coding in it, but not game stuff. And not very often. I'll code if something needs doing. But yeah, I didn't stay in the industry really because, you know, if you have a hobby and then all of a sudden you do your hobby for a job, which on paper sounds awesome, the problem is when you want to break from your job and your job is your hobby, you don't have a hobby, or at least I don't. And then I was finding myself with, like, you know, it wasn't good for my mental health. You know, not having coding as a hobby. So I decided to just not follow coding as a job. I still code every day, like multiple hours a day, but for creative endeavors. Yeah, don't call me lifting. I agree. You kind of have to weigh up at the beginning of the project what's best for your project. because, and it's also about not, like obviously not reinventing the wheel, but making a game with your own engine and making a game with something like Unity are very different experiences. And if you just know you're not going to finish a game in Unity because you don't like making games that way, maybe it is better to make your own engine, or vice versa. If you're trying to make a game, the most important thing is you finish the game. And that's different for different people. It depends how much money you've got to make it and everything, really. But I'm not necessarily trying to make, like, I am going to make a game with the engine to stress out the engine. But the number one goal is not the game. The number one goal is the creativity. Exactly. Code Red Games, yeah. Yeah, this game looks mint. Very popular in it. Look at that. 71,000 overwhelmingly positive reviews. You've also got to bear in mind that there are some people who think if you want to make a game, you have to make your own engine as well as that. And that's also not true. Or if they want to make a successful game, they got to make their own engine. And that's not true. Final Fantasy VII Rebirth was Unreal Engine. Or the new Oblivion game. It's Unreal Engine there, very successful games made in third-party engines. It's like, an analogy is, if you want to be a painter, do you want to be a painter to sell paintings, or do you want to be a painter to become a really good painter and you're not bothered about selling paintings? You might sell the occasional painting or whatever, but that's not the goal. It's a similar thing, I suppose. Although not really, because there's immense creativity even if you use another engine. Alright, let me just... Where are we? Alright, let's just restart this and then we'll just go through it. So, right, we're on the sequence node. So we're going to tick with the sequence node. And now we're on the action node. Running the action node. And then we run the action node again. And now we've finished running the action node. So we find the parent. The parent was the sequence. And the behavior state was success. So we need to go to the next one in the sequence. Set current node. So it's a selector node, this one. So we're going to tick on the selector node. Consecutive. So we're going to set the current node. Which is an action node. I'm going to tick with the action node now. Okay, so we're going to get this action node. Tick again, and it's going to finish. I'm going to find the parent. The parent's a selector. And it's succeeded, so we need to find the parent of the parent, which is that sequence node. Tick with that again. And then we need to set. So there shouldn't be anything to set now. Good. So we find the parent, which is a root. And we're going to tick the root. So we've gone back to the root and we're trying it again, which I think is fine. Yeah, so it's just going to basically loop over the behavior, which is what we want. I think it's working. And Jenny has stopped, which is great. Because Jenny's now, the behavior is acting on Jenny and it's not doing anything. So if we just open, we need to put basically a condition time of day range. So what time of day does, I think it's time of day 7, so we'll say from 7 till 8 we can do this behavior tree. So when it gets past 8 o'clock, you should just stand still till 8 o'clock because the behavior tree doesn't do anything. And then when it gets to 8, the time's down here. When it gets to 8, so in 1 minute's time, she should start walking because the behavior tree should become unavailable. So let's see what happens. 20 more seconds. There we go, and she's off now. So the behavior tree is no longer applying because we set that condition. And she just goes about her normal day. So the behavior tree, the idea behind that is when certain conditions happen in the game state, we can have the NPC react. So she's on a default patrol now. But then, you know, if something happens, like I stole something from the shopkeeper and she was nearby, she could run a behavior tree on that condition and it would tell her to do something specific. So we need to do a kind of like a big... So we put that condition there that this behaviour tree is only active between 7 and 8 in the morning. So when we tick the behavior controller, there's no brain state. I think that's really what happens. That's why it doesn't. That's why the patrol isn't allowed to continue with his default patrol. I need to set up some kind of interesting test case so I can film it for the YouTube video. Right now, just standing still is not very interesting. Put a condition that I go into a trigger. If I go into a trigger, she should stop and she should say like, hey, what are you doing in that trigger? These pink things are triggers. Triggers are just regions in the world that cause things to happen. Fast travel. All right, let's check that in. How's it going, Nuke Bird? Autograph CPP file. Oh, I don't know if I can manage that. How are we doing? You alright? Got behaviour trees working just now. It's not very the demonstration's not very exciting, but they do work. So Jenny's patrol now has a default behaviour tree called behaviour test, and then this is the behaviour tree, and this behaviour tree fires from 7 till 8 in the morning, so for 1 hour. So when the game launches, it's 7 in the morning, and it's just basically like it allows, so it comes down here, so every frame it's evaluated, so it goes like, right, and a sequence means this has to succeed for then this one to start firing. And a selector is, if this succeeds, it doesn't have to bother doing that one, it just goes back up. And these actions here, this behavior action test has a tick. Find it. Behavior action test has this tick which just fires this, it's just pretend code which just increments a number, and if it gets past 1 it returns success. So the idea is I can put little bits of logic in here now, these action nodes, and these can get evaluated every frame, and these logic can be anything. So I was going to set up a situation where if I walk into a trigger and the behavior tree is firing, it'll test if we're in the trigger, and then Jenny will speak and say, what are you doing in that trigger? Yeah, it's nearly done. Well, the actual bare bones is nearly done. I actually need to write up a few of these tests. And then I also, the second part of it, I've got these activity nodes which don't really do anything. And I want to be able to put these trees in the activity nodes. So when she's on a patrol, so she'll travel to somewhere, and then She'll travel to somewhere and then do an activity, which will be one of these trees. And because this is linked directly into the code, I can make the activities reactive to what the player does. So they're not just programmed like animations. If the player does something... So the one example I've been using is you're in a shop and you steal something, and if Jenny is there in the shop, she'll have one of these nodes that will react to seeing something being stolen from the shop, and she could say something. Yeah, cool, man. Yeah, so the logic is right now, so the actions have variables. So this is just a sausage bacon enumeration. So that's here in the action. So you could put anything in here. So you could set the variables, and then the logic is like, yeah, the sequence or the selector. But then you could do things. There's other nodes that I've not done called decorators. So you could like add a decorator node, and that could do something like invert the result. The only kind of logic that I've got is the sequence is like an AND gate. So if this succeeds and this succeeds, then this whole sequence succeeds. This is an OR. So if this doesn't succeed, try that one. If it does succeed, continue. Like you evaluated success. And then I've just said, how do you want to evaluate these nodes? So you can have consecutive or random. So the consecutive will go from left to right, and random will fire randomly. We'll pick one at random. So you could have like random actions, Yeah, familiar behavior tree. Yeah. So that's it basically. So yeah, I mean, it's down there now. So I started this. So it's taken about 2.5 days to make it all, which isn't that bad. So now I just, instead of these test actions, I want to author some interesting actions. And I'll do a bit more reading and see what other kinds of nodes could be useful. I expect what I'll do is I'll leave it at this, and then when I'm starting implementing the game for real, I'll add more when I need them. And another thing you can do is you can have multiple trees, and then this is evaluated from left to right based on these conditions. So this condition is like 7 to 8 in the morning. If that fails, it'll start with this one, and it might have more conditions. So you can have multiple trees as well. Yeah. Parallel nodes. I think parallel nodes, like, I will definitely put them in if there's a use case. I don't know. I might be able to do it all in code though. I have to be not too careful to go too game designy. Like, if you don't know how to code, this is very useful. If you're just like a designer and you want to design an NPC behavior, parallel nodes might make sense. But if I can just do it with code in one of these actions, then it should be all right. So the nodes are conditional, yeah. So you can put conditions here. Sorry, I misread that. And these conditions are just like authored in the engine. E conditions and G conditions. So engine conditions and then game specific conditions, you know, like this character has less than 20 HP or something. So yeah, each node is conditional, yeah. And the whole node tree is conditional. Well, the whole behavior is conditional. And then each node is conditional. So yeah, like this behavior tree has a condition where it only applies from 7 to 8 in the morning. Yeah, so rather than have a conditional node, the condition's on the node to get fired, you know. If if it doesn't meet the condition, it's not there, essentially. It pretends the node's not there. But I do that on all of the nodes. All the nodes have conditions in every single events and conditions, so they can fire events as well. So say you want to get notified when this particular action gets done, you could send an event there if you wanted to, and then anyone listening to that specific action can listen to it, or a sequence or a selector or whatever. But yeah, it's good. So yeah, I need to just basically, so tomorrow morning I might think about how I'm gonna do an interesting, so I'm trying to make a YouTube video about it as well, so I need an interesting kind of like demonstration. All this does now is it waits. Jenny the NPC just waits because these actions don't do anything, they just increment numbers. If I can find it. Yeah, here we go. But I'll put something in like, you know, this action might be like wait until, I don't know. I'll have to think about it. I'll think about it tonight. But yeah, cool. There is some bugs to do with the UI there. Like I've made a note of that. So that she thinks she's talking to me there, and she's not, just because there's some problem with the ordering of, if she wants to fast travel and you talk to her, she'll fast travel anyway. I think that's what's going on, even if you're mid conversation. Right, anyway, I'm gonna have to head off, I think. 5 o'clock here in the UK. But I'll be back here tomorrow at like 9:30 in the morning, GMT, and we'll make an interesting use case, an interesting version of this tree. And then that system's done, which will be awesome. Move on to something else. The next thing is going to be, I want to implement combat with this. So I'm going to load another rig that I've got, which is a scorpion enemy thing, and it has some attack animations, and I'm going to try and do the whole combat with this. Should be good. So we might even get onto that tomorrow. But anyway, I'm going to head off, and yeah, stream tomorrow. If you don't catch the stream tomorrow, the VOD will be up on the Twitch page. Alright, see you later guys.